The atomic bomb. Just the name evokes a sense of dread. It is a weapon unlike any other, capable of unleashing unimaginable destruction in a blinding flash. But what exactly makes this weapon so powerful? What forces lie dormant within, waiting to be unleashed? At its core, the atomic bomb is a device that taps into the fundamental building blocks of matter itself: atoms. These tiny particles, too small to be seen even with the most powerful microscopes, hold within them a tremendous amount of energy. The atomic bomb provides a mechanism to unlock that energy with devastating consequences. Understanding the atomic bomb is not just about grasping complex physics, it's about comprehending the immense power we hold as a species. The power to harness the forces of nature for both creation and destruction. This duality is at the heart of the atomic age, an era we entered with the detonation of the first atomic bomb in 1945. The atomic bomb's power originates from a process called nuclear fission. Imagine splitting a tiny atom. When this happens, a tremendous amount of energy is released. This energy, though invisible to the naked eye, is what gives the atomic bomb its terrifying power. There are two primary types of atomic bombs, both relying on fission uranium bombs and plutonium bombs. Uranium bombs use a highly enriched form of uranium, a heavy metal found in nature. Plutonium bombs utilize plutonium, a man-made element created in nuclear reactors. The process of detonation is a carefully orchestrated chain reaction. In a fraction of a second, a neutron, a subatomic particle, strikes the nucleus of a uranium or plutonium atom. This impact splits the atom, releasing energy and more neutrons. These neutrons then collide with other atoms, causing them to split as well. This process repeats itself, creating an exponential release of energy, an atomic explosion. The energy released in an atomic explosion is not just immense, it's fundamentally different from the energy we encounter in our daily lives. We're familiar with chemical energy, like the kind released when we burn wood. Atomic bombs, however, release nuclear energy, which is millions of times more powerful than chemical energy. When an atomic bomb explodes, this energy manifests itself in several ways. First comes the blinding flash of light and searing heat, capable of vaporizing anything in its immediate vicinity. This heat is so intense that it can ignite fires that rage for miles. Next comes the blast wave, an immense wall of pressure that expands outward from the explosion at supersonic speeds. This blast wave levels buildings, uproots trees, and tosses vehicles around like toys. Finally, there's the radiation, invisible but deadly energy that can penetrate the human body, causing severe burns, radiation sickness, and long-term health problems, including cancer. The true horror of the atomic bomb lies not just in its immediate destructive power, but also in its long-lasting effects. The bombings of Hiroshima and Nagasaki, Japan, in August 1945, serve as stark reminders of this weapon's devastating legacy. The bombs, nicknamed Little Boy and Fat Man, killed an estimated 129,000 to 226,000 people, most of them civilians. The cities were reduced to rubble in an instant, and the survivors faced radiation sickness, cancer, and other health problems for decades to come. The atomic bombings of Hiroshima and Nagasaki marked a turning point in human history. They ushered in the atomic age, an era defined by the constant threat of nuclear annihilation. While the bombings remain the only use of nuclear weapons in warfare, the threat persists to this day. The atomic bomb, a testament to human ingenuity and a symbol of our capacity for destruction, stands as a stark reminder of the fragility of peace and the importance of preventing the proliferation of these devastating weapons.